Welcome to Dozochem. This video covers orbital diagrams. An orbital diagram uses boxes to represent orbitals. So an s orbital, you're going to use one box. A set of three p orbitals, you're going to use three adjacent boxes. And a set of five d orbitals, you're going to use five adjacent boxes. To represent the electrons, we're going to use arrows. And rule 1, when we go to do this, is called the Pauli exclusion principle. If you have a pair of electrons in the same orbital, they must have opposite spins. And what that means is one arrow up and one arrow down. So you would show it like this when you have a pair of electrons in the same orbital or the same box. Second rule, it's called Huns rule. Huns rule, you want to spread out electrons if possible to obtain the maximum number of unpaired electrons with parallel or same direction spins. So imagine you have an electron configuration and it ends in P3. Because it's P, you're going to have three boxes or three orbitals, and we have to decide where to put our three electrons in those orbitals. So what you don't want to do is put two of them in the same box as a pair, and then put the third one in the next box and leave a box empty, because according to Huns rule, we want to spread them out as much as possible. So we're going to put one in each box. And don't forget the rule that you want to make them all go in the same direction. So never pack them in and leave a box empty if you can spread them out, and be sure to point them in the same direction. A couple of quick definitions. Paramagnetic means the particle, either the atom or the ion, has unpaired electrons, and diamagnetic means all electrons are paired. So now let's imagine an electron configuration that ends in D6. As we mentioned previously, you wouldn't want to pack all six of them into just three boxes if you've got two empty ones. Instead, you want to spread them out as much as possible. So you can't have six unpaired, but you could have two in one of the boxes, and then you could spread out the other four into the other four orbitals. So the bottom one here is the correct orbital diagram, and you can see there's 1, 2, 3, 4 unpaired electrons. And if you have unpaired electrons, you would say that it's paramagnetic. Okay, so let's end by doing a couple of examples. We want to determine the number of unpaired electrons and state whether S and CO2 plus are paramagnetic or diamagnetic. So let's start with S. Here's its shorthand noble gas electron configuration. And let's look at the end of the configuration. It says 3p4. So because it's P, we have three boxes, and we have four electrons. So we certainly don't want to put two pairs in two of the boxes and leave one box empty. We want to spread them out as much as we can. So we do have to have one of them paired, but then we can keep the other two unpaired in the other two boxes. And the two that are unpaired, make sure you point them in the same direction. So two unpaired electrons. Because we have unpaired electrons, we'd say that sulfur, or S, is paramagnetic. The other one is an ion, CO2 plus. So first you may want to write down neutral CO. And then definitely remember the rule that if you have to remove two electrons to make CO2 plus, you want to remove the valence S first. You don't want to start taking away the D's until you've removed the valence S. So right here is the correct shorthand noble gas electron configuration for CO2 plus. So it ends in 3d7. So because it's D, we're going to have five orbitals, or five boxes. And rather than packing them all into four of the boxes, we're going to instead spread them out as much as possible. So we would have two pairs pointed up and down according to the Pauli exclusion principle, and then the other three would be unpaired and spread out in the remaining three boxes and pointed in the same direction according to Huns rule. So if we were asked how many unpaired electrons, you'd say 3 to represent these three here. And because there are unpaired electrons, you'd say that CO2 plus is paramagnetic. So that's it for this video. Good luck.